Good evening. Welcome, students. I'm your online instructor, Frank Jacobs, and today we will talk about or do an exercise in deriving the least squares regression line using two variables, the x, which is the independent variable, and the y, which is the dependent variable. Remember, y is a function of x, or y is dependent on x, y gets its values from x. We're going to be calculating also the covariance of the set of data x and y, the standard deviation and the variance of those two values, and we are going to be calculating the B1 and B0, which is the fixed costs and variable costs respectively. We will calculate the coefficient of correlation R, and R squared, the coefficient of determination. To start, we would enter the sets of values x and y. They are in ordered pairs. Here you see the values x and y, all the x and y values. And then to get the totals, we will follow the prompt and sum the values, and the resultant sums will be put here. So this would be sum of x values. This total is the sum of the y values. This sum would be sum of the xy values, and this would be sum of x squared values. This would be the sum of the y squared values. Having done that, we can begin to populate this side here. Here we have x bar is equal to, and we know that is the sum of x, the sum of x divided by 10 when the result is placed in this cell, is 6.5. We do the same for y bar. Y bar is the sum of y, which is this total here. That's the cell address is B12 divided by 10, and that gives you the 24.186. That is the y bar. The covariance of x and y is calculated by applying the formula 1 divided by n minus 1 multiplied by the sum of x squared minus the sum of x, and that is squared divided by 10. That gives you this value. S squared sub x, which is shown here, that is the standard deviation, the variance rather, of the x values, would be given by the formula, not shown, but it's in the formula bar here. 1 over n minus 1, that would be 1 over 9, times, open brackets, the sum of y squared, the sum of x squared rather, which is in this D12, minus the sum of x squared, which is a times a divided by 10. That calculates the covariance. The variance, the covariance of x, the standard deviation of the x value would be obtained by finding the square root of this value. So it is equal to, in this cell you put square root, open brackets, the square root of, and in parentheses you will put the cell address where the variance is calculated, which is at B17. So square root, open brackets, close brackets, B17 gives you the standard deviation of the x values. And we calculate the standard deviation of the y values, which is calculated using the formula 1 divided by n minus 1, in this case 1 over 10 minus 1, 1 over 9, times the square of y squared, the square of y squared, this is the square of y squared minus the sum of y squared, the sum of y times the sum of y, divided by 10. That gives you the variance for the y values. Then we calculate the the standard deviation for the y values. So we're going to find just the square root of the value we just calculated. Equal, in this cell, we place the values in this cell. That is equal to SQRT, square root of B19. B19, we're using the cell addresses here rather than the actual values that's displayed. And we next calculate B1, that is the variable cost factor here, variable cost, and that is calculated by the ratio of the SXY, that is the covariance, which is at B16, divided by S squared X, B17, divided by the covariance of XY divided by the variance of X, and that gives you B1, the equivalent fixed variable cost. Now for the fixed cost, B0, or the constant term, B1, which I've been referring to as the variable cost in accounting, is the variable cost. It's in fact the coefficient of X is the gradient of the least squares regression line. So y equals B0 plus B1 times X. Okay, B0 is the constant term, or the fixed cost in accounting terms, and that is calculated by y bar, which is at B15, minus B1, which we've just calculated, which is at B21. You click on B21, times B14, which is X bar. So y bar is equal to B0 is equal to y bar minus B1 times X bar. R, which is the coefficient of correlation, is obtained by finding the covariance of X and Y, SXY, which is at B16, divided by the product of the standard deviations of the X and Y values. So it'd be divided by, open parenthesis, you have to use a parenthesis in this case, B18, which you notice is S of X, the standard deviation of X, and B20, the standard deviation of Y. So the covariance divided by the product of the standard deviation of the X and Y values, that will give you the coefficient of correlation, and that's tell you the degree to which the data are correlated. This in this case, this is fairly high. It's 0.871. Remember, the maximum you can get is plus or minus 1. R squared is just obtained by squaring the covariance, the coefficient of correlation, which we just calculated. That is at B23, so we click here in this cell, the B23 times B23, that is the value multiplied by itself, that is in fact squaring the value, and that is placed in this cell as shown here. So that is the coefficient of determination. This coefficient of determination refers to the proportion or the variation in y in the dependent variable that is explained by the variation in the independent variable. The balance residual percentage refers to the unexplained variation. That is essentially what this exercise is about. That is the end of this video lecture, and this is followed by assignments which you would have to do pertaining to the same concepts, calculation, the regression lines and so forth. So that's basically what you have to do next. See you next class, next lecture.